Hi everyone, welcome to my channel. This is Leo, and let's do some more LeetCode problems today. Today's problem is called a frequency of the most frequent element. So the frequency of an element is the number of times it occurs in an array, and we were given an array nums and an integer k. In one operation, you can choose an index of nums and increment it by 1. Return the maximum possible frequency of an element after performing this k operations. So this is a pretty tricky question, and at first glance we would think of it as a very simple question that tells us to calculate the most frequent element here. But actually no, the most frequent element is not in the array. We have to modify the array and find the most frequent element. So the first example tells us we have 1, 2, 4, and k equals to 5. So at each time, we can increment one element by 1, and at most k times. So if we increment 1 by 3 times, and we increment 2 by 2 times, so we got 3/4. Therefore, the maximum frequency will be 3. Okay, so the same thing happens here. So we can say we have 5 operations. We can add 4 to this one, add 3 to this one. So now the 4 has the frequency of 2. Or we can add 4 to this 4, making it 8. So we have a frequency of 2 of the number 8. Okay, so that's the maximum number. So how do we approach this problem? This is a pretty tricky one, I would say. So let's say we have some numbers, okay? Let's say 1, 2. And I want to increment things to make it with the most frequency. So obviously I should increment this 1 to make it 2, so that I can get a frequency of 2, which is the maximum. Okay, so at this time, if k is larger than or equal to 1, that would be great. Okay, so how do we do this? That's pretty easy, to be honest. Let's say we have 2 elements here, right? So the maximum frequency would only be 2 2s. So the total would be 4. Okay, so that works all the time. So let's say if we have 1, 2, 4, so the maximum total would be 4, 4, 4. Total would be 12. So the sum now is 7. If we subtract it and we got a k larger than or equal to 5, we should at least be able to form an array like this, 3/4. Okay, so that is our trick in this problem. So we just maintain a prefix sum and calculate along the way, and then maximize the length, maximize the frequency. Okay, calculate the frequency. So first, we need to sort the array. And after sorting, we should get something like this, 1, 2, 4, and we can iterate from the first element. But since we're using a prefix sum, I think it's better to put the left pointer out. And prefix sum equals to 0. And we will have a max frequency, which is 1. But it doesn't really matter 1 or 2, but 1 or 0. But since we have elements here, it should be at least 1. Okay, so next we'll iterate through the nth array. So prefix sum, we'll add nums r to it. Okay, so when there's a limit there, okay? There's a maximum limit. If let's say we don't have enough k's, let's say we have k equals to 3, and the maximum we can get is 7 plus 3, okay? Is 10. And this total will be larger than this maximum we can get. So this will be an invalid, okay? So when it's invalid, we should shrink from the left side, okay? So when nums right times right minus left plus 1. So here we have 4, the number, and how many times? 1, 2, 3, 3 elements, 3 times, okay? So if that is larger than prefix sum plus k, we'll have to shrink from the left, okay? I write it outside, okay? And after each operation, we will update the max frequency, okay? Maximum frequency, and it should be right minus left plus 1, like this, like what we did here, okay? And return the maximum frequency. Cannot find symbol. Okay, nums. Okay, it passes all the test cases. So we have time complexity n. Oh no, n log n, because we have the sorting. Okay, and for the space complexity, it's log n to n depending on the sorting algorithms you use, but generally it was considered of 01. Okay, let's submit it. Oh, we see a problem here. So there are many large numbers, okay? So it might cause integer overflow. So for this, we can just change it to long. And yeah, prefix sum goes here, and I think here we can add a long like that, and we can use this test case. Okay, it passed. So this should be good. Yeah, there you go. Thank you so much for watching. I think that's it for this problem. It's a very challenging and tricky problem, but I highly recommend it. So if you like the video, please like and subscribe or leave me a comment. I'll see you in our next video.